Good afternoon, ladies and gentlemen. This session about the SP computer and Dr. Rifki Sadikin will be presented in here. Please, Dr. Rifki Sadikin to present it about this session.
Thank you, Pak Sofyan. Good day for everybody who attend this virtual meeting. I think most of the attendants are from Astronomy ITD, right? So today I will present an infrastructure at BRIN, which is open to be used for the research. And I think there is some, I put some example also for the problems in astronomy. But I myself is not an astronomer and I'm not doing research on the astronomy either. So I just presented technical aspect of the how to use the HPC, and I already prepared the presentation here. So the title would be Introduction to the HPC at BRIN. My name is Rifki Sadikin. I'm now the Director of the Research Center for Computing at the Electronics and Informatics Research Organization at BRIN. So today I will present first I will introduce the research centers first, short introductions, and then the HPC itself at BRIN and how we plan to extend it in the near futures, and how to having access to the HPC BRIN. And there is an example how we can use a module for astronomy, especially later on I think the name of the module is Rebound, which is the module in the Python. And then we have example how to do submission interactively or batch. So this is the research centers for computing. We have BRIN have one research centers focusing on computing, and we mainly focus on the scientific computing, and the problem could come from broad spectrum, and for these occasions is from astronomy, and we have researchers which has an expertise in the computational model methods, and also the computational optimization and implementation, especially implementation in the HPC environments, which has a hybrid or heterogeneous system like CPU, GPU, and also others platform. So we are open to collaborations with any fields, and one of the research group at our research center is computing for astronomy or astrophysics. The head of the research group is Ibnu Nurul. I think he's one of the organizers and presenters in this conference. And then I will present about the high performance computing at BRIN and how it would give capabilities for the researchers to use computing resources. So because of the integration of the many research institutions in Indonesia, into BRIN. If we can collect there was LAPAN, PPPT, Batan, and LIPI, and also the HPC now became integrated, and we can see the website of the HPC BRIN here, and actually the website are maintained well, and there are information how to access it, and also even there is a manual for application of the account. So for those who works on BRIN, we can. I will explain it later how to make application for the account, so we can access the HPC BRIN. But the manual is quite explanatory. You can read it one by one and how to use it. And so HPC BRIN provides computing service for public. Until now, it is free, but the requirement is for research only, not for production. For example, if we have research stations and the research station needs computing devices, then the HPC BRIN cannot be used. But if you have a model and we want to understand the model, want to simulate the model, and then the HPC BRIN can provide the computing capabilities. The system is based on OpenHPC, and we use resource management from PBS. So it's quite simple to use, but of course it needs experiments to use it. And for the access application, we can use, there is a platform at BRIN called Layanan Science. From here, you can see at line BRIN HPC. Then there is some services provided by HPC laboratory, and you can choose the layanan komputasi umum and ajukan layanan and so on. I will explain detail later. So it is until now free to use as long as it is used for research, when where the output of the research, for example, research articles or publication, and we just require you to acknowledge the system. So this is the specifications. The specification of HPC BRIN. We have two clusters, two kind of HPC. The first kind is CPU based. Most of the nodes are CPU. Until now, this is the specification. We have 18 nodes of the CPU workers. With the total, of course, is 648, and the total of memory is 2.3 terabyte memory of working memory. And this is storage, not working memory. Storage, cold storage memory. This is RAM. For working memory, for storage is a petabyte, around 3 petabyte. And then we have also GPU worker for nodes, but the GPU card is quite 5 years ago, quite old, Tesla P100 GPU. In these years, there is a plan, and actually this is already been executed. And in the November 2022, we hope that HPC Brain are extended. There will be 50 new nodes with each 2 times 32 cores, and working memory 256 gigabyte, and the storage total is 6 petabyte. And each of the nodes are connected in the high-speed connection InfiniBand with 100 gigabit per second. So there will be much higher CPU-based HPC at Brain in this year. So I think there we can provide the computing devices for many applications, especially in the computational science problem, like researchers from material sciences who works on the density functional theorem, or chemical sciences who works on the molecular dynamics, even for bioinformatics and astronomy and astrophysics. So we invite all the researchers, academicians to use the HPC here, and it is until now free for research. And we also manage the HPC for artificial intelligence and big data clusters. It is mainly consists of GPU clusters. We have DGX A100, which consists 8 NVIDIA A100 GPU, and DGX1, and also IBM Watson. So this infrastructure mainly for people who works on machine learning, who have data set and would like to learn from that data set for the neural network model. So these computing infrastructures are now being open and can be used for public also. So now I will deliver the third topics, how to use it and account application at the HPC Brain. So like the most of the HPC system in the world, we use a software module and job management to manage the software and also to manage the job. The benefit of module based is for those who use the same softwares, didn't need to install in their local directory in the local home. For example, people who works on the material science use software called GROMACS. Then we can install the GROMACS as a module, and many people use Python, and then we can install the Python as module. So module is actually like a plug and play software where you can plug the module and use it, or we can choose from the options in the module. Of course, not all software modules are available now at HPC Brain, and we encourage people to use it. And if you find some modules are not available, you can contact the administrator, and then they can install it for the community. So module usually used by the community, which they have the same interest and the same program, the same software module that being used for their simulation. And for the job management, we use PBS, why we use PBS? Because it is easy to use, where user log into the login node, and then can ask the resources from the queue or petitions. And there are two modes. First is interactive, that we can ask the resources and we can use it at that time, but it limited on our only. For the longer job, we can use the batch system. We can submit the job and then leave it and wait for it until it finishes. Of course, again, the specification, the requirement is different for many, for each problem. For example, people who works on the quantum physics require very long time job, and then also needs many nodes. But other problem maybe not require that kind of requirement. That's why cooperation between users and admin we are now support it, so we can know what is the real requirement from the users. Then how to having applications on the access and account. So for the HPC users, first you have to register the account through ELSA, which I can show you here. So here, this is, if you have an account of ELSA, just fill it. It use BRIN single sign-on. So for example, for me is I already have a BRIN account. So after you have the ELSA account, we can apply the applications for HPC BRIN here, and we can apply the layanan komputasi umum. Yes, and then ajukan layanan. Just fill the form, what we want to do, and then what the software you use, and then what is your output, whether it is thesis, proceedings, techniques, and so on. But we didn't require the output exactly, but this is for our notes. After that, you can see at the transaction how the SPC how your application are processed. We can see here, for example, for me, I applied the account at 27 April, and then the administrator are giving me the account, which is the username is RIFK001, and I also put my public key here, so we can access machine to machine. And these services can be used by non-external BRIN, not only for the internal BRIN. As long as the the requirement, the softwares, the computing resources are can be supplied, then it will be processed by the admin. So this is the account application. I think I already present it. First, we can create the account and then make application for HPC BRIN usage. And then when the access are given with secure shell, where now we choose to create a login mechanism machine to machine. So you have to generate your public key, especially for the computing devices that being used by the users, whether it is laptop or desktop. And there is some guidance for creating the key, and after that there will it should be very easy to use the SPC. So for login, we can use a secure shell with the address login.spc.brin.id with the username written at ELSA-BRIN. So the username will be given by admin and you can use it. I will demonstrate it. Here, for example, I use Mac machine, and we can open the terminal and then just do the secure shell, -l, your username, and then the address. Because it's already machine to machine, this actually password for my private key, not for login to the SPC machine. Then this is the login node. So if you see here, we have the machine is the the server first server that come when we are login are login node, and this is my name. This is my account, RIFK001. Then you can read the manual on how to use the Mahameru HPC, and we give also the example here. But of course, this is very simple example. Okay, now after we have account, what we do? Of course, we want to do something, right? We want to do computation, and here I will demonstrate how to use the rebound module. Again, this experiment is intended to show how to use SPC BRIN, not for expert at rebound module, because I'm not the user expert on the rebound. So maybe for those who haven't used rebound, maybe I can show you what it is. So this is just one of example. If you have any module, any programs, then actually can use the SPC BRIN as long it is legal. Mean that if it is the proprietary software, then you have to provide the license. And then this is the rebound. Rebound is software package that can integrate the motion of particle, and so on. You can read here. And interestingly, it is already ported to the Python. So here we have Python. So we can use C or Python when working with Rebound. So it is actually library, which is provided in C and Python. Both can be implemented here, but in this occasion, I will only use Python. And the installation is quite easy, just pip install Rebound. But they suggest suggest us to use virtual environment. And I usually use virtual environment also for different projects because different projects usually require different modules and so on. So here, the first maybe the issue is what module so there is first I want to explain about the environment modules first before we dig into the Rebound. So you can follow my example if you already have HPC Brain account. So the first one is what is module and what is user application. So module actually implemented, compiled by the admin, and it will provide the softwares to the users, and users just can use it easily without needed to install again every required libraries or softwares. So I will show you here. So now I'm at the login node. We can see what module already available in the HPC Brain. So as you can see here, there are module for compiler. There are module for the, I think this is a library for numerical methods like linear algebra package, LAPACK, and so on. There are module for, this is for Python, Anaconda, and Amber is for molecular dynamics, and so on. Even we have a compiler with many different versions. And this is GLOMAX, LAMS, MPI, and so on. So module basically provided by administrator, where we can use it without installing and so on. In our case, we would like to have a Rebound module, Python module at the Python environment. So first, but I would like to, okay. So here, actually, I already at the login node, and if we see it, this is the Python version that already there, and but I suggest you to load the Anaconda version 3 for not making things complicated. And then we can check whether the ribbon is already there or not. I think I already installed it but I already uninstalled it. So what we do, we just install it. But so if we go to the installation, the ribbon already registered to the pipe PIP, and you just call pip install ribbon. In my example, I'm not using the virtual environment. And at HPC Brain, if the Python module is not being there, it will be installed at the home directory, not at the admin directory or root directory. So you can see here, if I done the pip install ribbon, the system will detect that the normal site package is not writable. Then it will be installed locally at your home directory. Actually, it's located at, I think, in the local. Lib, and so on. Yeah. So it will be installed in your directory. So, if the module is not being there, you can just add it in the home directory. And right now we can check. Okay, no. Import ribbon. It should be okay. So now we have a ribbon module at our system. So the installation is quite easy, and it would be different problem for different kind of computation. Sometimes it is easy, sometimes it requires a library, sometimes it needs a module. So if the people who use the software there is a group, a community who use the same software, I suggest to be installed as module. So not everybody. So it will make your life easier rather than install it again. So if there is no module provided, then we can install it locally at our home directory. For virtual environment, actually, you can read it at this. It's actually not quite complicated, but if you are actually Anaconda provides Conda environment to create virtual environment more easier than this. So you can use Conda here, and this is actually the same objective with the virtual environment. And this is especially for those who have many projects with different software module. It's better to create a virtual environment. So for example, here, on the same. So for example, I create many environment, and I can install it locally. For example, this is astronomy pack, and everything module for this environment will be installed here, and so on. So now we have the Python module, Ribbon module already been installed, and we would like to run the simulation. So here I use an example from the website, Ribbon website. So here, for example, there is an example for simulating Saturn's rings, where we have initial conditions like this, and then we apply the simulation, and this is the final the result of the simulation. But this is a very simple actually I already translate it into the Python script, and it provides in here. But so maybe later on. Here, so the coding is already been here. This is for the Python script for the Saturn's rings, and it already become one script. And for the image, I plot as I save it into the file, and this is the simulation sim.integrate, and then this is the result. So back on the here, we can use interactive mode or batch mode. So what is the difference? Interactive mode, the HPC system will give us the results, and then we use that results interactively, where we can execute any command. But it is usually used for the preparation, whether our script already working properly or not, and then we can use the second mode, which is called batch mode, where you just put the job, you just ask the job to be run by the HPC and wait it until it ends. So if it is required like more than 1 hour or more than 1 day, this is a better option for the using HPC system. But I will go through the example now. First, we would like to ask the results interactively. The script already provided. You just type mlogin. As long as the nodes are available or the cores are available, the system will give you the resources. And here, actually, this is just for preparation. If you remember, the at first we are at the login node. After we ask the resource interactively, we now at the Puspa 32 node. So actually it's similar. We'll make new example. Then I just put the I just copy the code. I think this is the comment. Here. Oh, I forgot. This is cannot be here. This should be at login. Okay. So for reaching internet, we should go back to the login node. Then we can copy it. We can clone the Git, and now we have the code. So I will log in again to the interactive mode. And now we are in the machine of Puspa 32. And
Dr. Rifki, sorry, I interrupt you. We can see the terminal.
Yes?
We cannot see the terminal.
Oh, I'm not sharing the desktop. Oh, it's because it's different desktop, right? How about now?
Yeah, you can see it.
Because it is at different. Okay, now I think we are now in the Puspa 32. I will remove first the input and output. So now there is no input and there is no output of the program, and I think I need to change the location because this example actually different example. Oh, okay. Okay. Apa tadi namanya? So I just edit the target of the file. Okay. Now we can load the Anaconda version 3, which is already provided by the admin as a module. Then we can execute the script just like that. Because everything now already been in the one script in here. So the program actually execute every command here until it produce two figures. The first figure is for initial pictures. The second one is after the simulation. So we can come back to the, we can go to the, here, it's already finished, and we can see this is the file which produced by the simulation which I execute recently. How we can see the image? So we have trick here. If you want to see the image or result of your simulation, because we use a secure shell, can use Xsheet from the interactive mode, and I'm also exit from SSH from the secure shell. We can put -y. So the SSH, the secure shell can give the graphics, so we can see the image and so on. Even if there is a movie, we can see the movie which run on the HPC, but the display are at our machine. So for example, we have already, we want to see the result of our simulation, which the output are figures in PNG format. So we can use a program. I forgot the name of the program. AOG initial. So it will draw the figures in our terminal. Here we can see this is the initial formations of the Saturn's ring, where the node here I think is ice particle, and after that we want to see the final results of simulation. So this is the final result after, I think because some simulation on the gravitational, the effect of gravitational, then it just like a clump together in the, these particles are clumped together and so on. So this is interactive mode, where we can run it and try our script first before it being submitted to the batch. Especially, we want to check whether our script is working properly, or for small model or small data. So this is the interactive mode, where you can we can use it for preparation. And then now I think I will explain the second mode, which is batch mode, where your job are being added to the queue, where the queue are already been given by the admin of the HPC Brain. We have several queues where you can use it accordingly to the simulation. We have, I think I have the presentation before. The pictures of this. So before we use, we create the batch system. We should understand what QR provided in the system. And until now, we have, we call it single node sort, multi-node. Sort time is 24 hours. And user can use like until 4 nodes of computers of server, but only for 24 hours. And then we provide also long queue, which can be last for 7 days. It actually can be set dynamically, and if there is some requirement from the astronomy community, then we can provide it as long as the resources are there, because the resources are limited. If the queue are full, then there will be a problem. But the chairman of BRIN said that if the system are full, the queue are full, we can request to him, to the chairman of BRIN, to add more resources at the HPC BRIN. And we also have GPU queue for those who use GPU, like for machine learning. And we plan to integrate these machines are in Tangerang Selatan, the GPU cluster, but we are now planning to integrate it so it can be used from single node, single login node, and also can be used by multi-users and can be used multi-user and sharing. And back to the rebound, how we can use batch mode for our simulation. So in principle, it's similar with the interactive mode, but with addition, you have to create the script for PBS now, which resource you ask. For example, here, this is PBS min n. What's the name of job? This is actually just naming our job. I naming it Saturn rings. And then which queue we ask, which partition we ask for this job. For example, this we ask CPU queue. And then how long the wall time? This actually like 4 hours. But because the queue are is 24 hours limited, if the wall time is more than 24 hours, then it will be killed automatically after 24 hours. So this is so we have to. This is come from experience also, how long that the execution time needed. And then how many nodes we require, we ask. In this example, we require 1 node and the number of processor is 16. So we can ask more than this, for example, because the system at the BRIN now, each node contains 24 cores and having two processors. So if you, but we have, for this queue, we have limitation. We limit until 4 nodes. You can ask until 4 nodes, and processor per nodes-nya at least 24. Then after that, after we require, we command the PBS to give us resources. We just do the same command at the interactive mode. For example, here we load the module of Anaconda and then running the Python script, which contains a rebound. So actually, whether it is PBS or SLARM, it's similar, but the terms are different. In SLARM, we use partitions. In PBS, we use queue, and then after we create this script, so I will going back to the command line. So we don't need to log into the interactive mode. Everything must be done at the login node. But first I will remove the PNG. So here there is no output of the program. We would like to submit as a job at batch system. I just changed this because this is for this session. I think the folder name is IVC session. So you check whether the comment is correct or not. If not, then it will return it will produce error. And now we have PBS, and we have then we can submit it with msup, and then with the full path to the PBS script. And this is Saturnin PBS. So I just run this script, PBS script. You see that the system gave me the Puspa number 2 with the process. This is the name of process, and we can see what is the status. So it actually still running. The job ID are here at the queue or CPU queue. Job name are Saturn rings and so on. We can check again whether it is still running or already finished. So if there is no at the list of the current job, then your job already finished. We can see the status of our if it is produced the output in the. So you can see here, this is the 10243. So if the extensions contain E, it means the error messages are written here, and O is for the output. So we can see whether it contain or error or not. It's empty, means that the program is doing well. And then output is not written, but because the script, the output are written in the file. So we can see now. This is the result of the batch where I call the batch system, and you can see the date 14 past 5 minutes for the final PNG and initial PNG. Again, we can see the results by if it is graphic by secure cells -y, and we can use some program to open it. So that's the example how we use the batch mode. And then my last presentation is about what to do next, especially if we have community who works with the same problem, how we want to use the HPC Brain. So I think it's better have a community who will know the technical aspect, and this actually at Brain we already suggest how to manage the HPC Brain and how we are assign some people to do administrating works as admin system or application administrator. And for the astronomy or astrophysics software, I think the Pak Ibnu already been appointed to manage the application. So if you have you have kind of requirement, what module and so on, then we can have solve module, or you have a community who works on the same problem with the same software like Rebound, then we can ask some one or two researchers to manage the software. So it will bring benefits to the community. It will make easier for the new researchers or students to use the HPC machine rather than everybody just working from scratch every time. So in the near futures, in the coming months, we would like to integrate the GPU clusters with the main HPC system. And also, like I presented in the earlier slide, we are planning to add more nodes, computing nodes. It's actually 50 computing nodes, which each node contain 2 processors, each with 32 cores. And we also have one special node where the working memory are very big. I think it's in the scale of terabyte. So if you have problem that require the data copied to the working memory, it can be done. It can be done. But the additions of the 50 nodes, computing nodes are maybe available at the end of this year, at November or December. And also the addition for the AI machines or GPU clusters are planned in the next years or 2 years after this year. It will be depend on how we use, how the usage of the HPC Brain, whether it is being used optimal or not. If the users are limited and are not being used by visitors in Indonesia, then maybe we are hard to add the computing nodes. But if there's many users and many softwares are being used, if there is some queue on the using of the system, then we can ask the BRIN management to add the infrastructures, especially for HPC. I think that concludes my presentation. If you have more questions, can email me at this address. This is the address for the research center, Pusat Riset Komputasi, PRK. And this is my mobile number. And this is my official email address. And if you have questions to the HPC lab, can ask the manager lab, Mr. Shambudi Irianto. It is actually staff at the Research Center for Computing. I think that concludes my presentation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Yes, this is about there is a question in YouTube from Daida. Can we use another interface like Jupyter Lab to run on BRIN FPG? Ya.
Bisa di copy di chat, Pak?
Oh, di copy di chat.
Ya.
Ada di chat. Di chat terakhir. Ini udah ada, Pak. To Dr. Rifki, can we... Oh, ada lagi nih.
Okay, the question is, can we use the interface like Jupyter Lab to run on BRIN HPC? Of course, this will be our job to provide the easy to use for the users. Actually, there is some frameworks or some software where we can install the Jupyter Lab, but until now there is still not provided in the HPC BRIN. If the community or some of admin are working on this, then it will be make it's very great tools for the people who work on this problem. So until now, there is no Jupyter Lab. I think what I mean is like you just open the like Google Colab, then open the script, and we still don't have it. But if you want to install the Jupyter Lab locally, it can be. You just install it at your home and then access it with the SSH tunneling, but it requires some works to do. So it's this, maybe I can share on the something like that. But again, this is a work on only for your home directory using SSH tunneling. For the submission job in the queue, we are still working on that. We still don't have a mean or a tool to provide a Jupyter Notebook where it can submit to the PBS system. In case of large size of output, of course, you can use it secure shell, there are command line tools like SCP, secure copy, or so there is HTTP, secure copy. It actually can be used to upload or download the files. Here STP. So the command is like this one, STP. Maybe example. This one STP, and then go to the remote. Maybe I will give you a sample now. Okay, for example, we have this file, but we want to having to our local node, a local machine. Then we can use STP to.
I didn't get that. Could you try again?
Okay, here I can use STP and then to the remote terminal. Here and then to the options of I think specification. Forgot. If we see rebound, yeah. So this is similar to the copy CP command in the machine, in the local machine. So the file now is being copied to my laptop. So there are several, I think there are also some tools which provide graphical user interface for copying file. But I think I don't have experience on the application, but there are some easy to use copy paste file to the remote machine. I think, for example, FileZilla and other tools. And I think if you use Windows, we can add the remote machine to our file explorer. So, but how about the data which the size are in order of gigabyte or terabyte? If we copy it, it requires hours or days to complete. There is an option to just come to the laboratory. The laboratory is at Cibinong. Bring your storage, external hard disk or other things which contains your data, and copy it machine to machine. It's more quick. It's quicker than copy through the internet, through the networks. So you can come to the laboratory if your data is large enough. If the transfer time is take a lot of hours or days. I think my answer, Sofia. Yeah, AirSync, you can use AirSync also.
And there's a question about Racings, RSINC, from Mr.
Hello, Pak Sofian, I cannot hear you.
About the question from Mr. Subhan in uh, RSYNC is also there. RSINC strip R from chat.
Moderator, there is no sound.
Oh.
Or in my machine only.
There is a question. Are you here? There is a question about.
I think it's your machine, Dr. Rifki. I can hear Sofian. I can hear Mr. Sofian clearly.
There is a question from about RSINC. Are you here, Mr. Rifki? About a chat from Mr. Subhan. RSINC is also there. Yes, any question? Maybe no question is time is over. We can break and insert photo. Okay. Please, I'm still to Mr. Nurul.
Okay, you're all, please open your camera because we are going to take a photo. Please open your camera.
Sorry, Raditya. I think
Yes.
Dr. Rifki is still not here.
Oh, yeah.
Right?
We
Maybe
can wait.
he has a problem connection.
Okay.
Tadi saya putus.
Okay. Can you hear us?
Yes, yes.
Okay.
Okay, please all open your camera.
Is there any more question?
No. No, No, no. And
Okay. Ready. For first page. 1, 2, 3. Okay, again. 1, 2, 3.
Recording in progress.
For second page. 1, 2, 3. Okay, for last page. 1, 2, 3. Okay, thank you.
thank you to
Ya, sama-sama.
and thank you everybody to make it Zoom meeting. Yeah. Okay, everybody. See you later.